It is the most famous object in the Bible and one of the least described. Genesis gives the ark 3 measurements: length, width, height, and almost nothing more. It never says what it looked like. No hull, no lines, no drawing in the text at all. Even the first word holds back the shape you would assume. Genesis does not call it a boat. It calls it a tevah, a box, the same word used once more for the basket of reeds and pitch that carried the infant Moses down the river. So this is a reconstruction of something its own source barely draws. What did it look like, and what would it really have cost to build? A wooden vessel the size these numbers demand, raised by hand, in an age with no steel and no machines. The text gives the dimensions and trusts the rest to the builder. Everything after that, we have to reason back. And it begins with the numbers, because the size comes before every other question, and the size is the first problem. 300 cubits long, 50 wide, 30 high. A cubit is a forearm, elbow to fingertip, which sounds exact until you ask whose forearm. The common cubit runs about 45 centimeters. The Royal Egyptian cubit runs closer to 52. Take the short one, and the vessel is 135 meters long. Take the long one, and it passes 157. That is more than 20 meters of uncertainty built into the first line of the plan, and the argument is old. 1800 years ago, Origen was already insisting that Moses, raised in Egypt, must have meant the larger Egyptian cubit. Take the short cubit, the conservative one. 135 meters, longer than a football pitch laid end to end, higher than a 4-story building, 3 full decks stacked inside. Now hold that picture, because the picture almost everyone grew up with is smaller and rounder and a long way from the text. A little curved boat, an animal at a round window. The text describes nothing of the kind, and the size creates a problem before a single plank is cut. Nothing grows 135 meters long. There is no tree, no beam, no timber on Earth you could lay down as a single spine for a hull this size. Everything long has to be built up from shorter pieces and then made to behave as one piece. The text does not say how. It leaves that to the builder. Joining wood so that a long hull moves as a single body, instead of tearing along its own seams. That is precisely the thing that has drowned the largest wooden ships ever built. There is one more number hidden in the first 3. 300 by 50 is a ratio of 6 to 1. Long, low, narrow. It matters, because the flood boat in the Babylonian version of the story, the one in the Epic of Gilgamesh, is a perfect cube. Genesis describes something shaped like a ship. Hold that difference. It comes back. But before the shape, the text names the thing. And the name is the first sign this was never meant to be a boat at all. The word gives away more by what it withholds. The same word that names a reed basket you could lift in your arms now names a hull the size of a coal freighter. And still, no bow, no sail, no mast, no rudder. Sealed with pitch and set on the water not to travel, but to float and not sink. This is not a modern reading. 400 years ago, Walter Raleigh worked out that the ark must have had a flat bottom, not the sharp-cutting hull of a real ship. The old reference books called it an oblong box, a floating house, never meant to be carried any great distance from the place it was built. The pointed prow, the mast, the rigging, those are the painter's additions. They were never in the specification. That reframes everything that follows. A vessel that cannot steer and has nowhere to go is asked to do only 2 things: hold together, stay afloat. The wood, the joints, the 3 decks, the pitch. Every instruction that follows serves those 2 ends and nothing else. This was never naval architecture for a voyage. It is a shelter meant to carry what is inside it alive through a year on the water, and to come through still sealed, which returns us to the material and the word we still cannot read. Now the material. And here the text does the strange thing again. It names the wood exactly once, with a word, gopher, that appears nowhere else in the Hebrew Bible, and no one since has been able to say for certain what tree it means. Hold on to that. We will come back to it. First, set the name aside and ask what the wood had to do. It had to come in long lengths, because a hull this size swallows enormous runs of timber. It had to resist rot, because it would sit wet, inside and out, for more than a year. And it had to be joinable, because nothing grows long enough to span the vessel. So the whole thing is an assembly of thousands of shorter pieces that must not work loose. The ancient world had a way of doing exactly this, and we know it from wrecks pulled off the seabed. Phoenician and Greek shipbuilders did not nail planks onto a skeleton. They built the shell first, edge to edge, and locked each plank to the next with a joint called mortise-and-tenon, a tongue cut on one board, slotted into a socket cut in the next, and the two pinned through with a hardwood peg. No iron. The hull became a single continuous skin, every plank gripping its neighbors. Underneath that method is a quiet piece of physics. Wood swells when it soaks. The longer those pegged joints sat in the water, the tighter they locked. The sea, working to prise the hull apart, was clamping it shut instead. A ship built this way does not loosen as it floods. It seizes. The shape helps too. A rectangular hull resists bending far better than a rounded one. And the 3 decks the text calls for are not only floors for cargo. Run 3 continuous decks down the length of a long box, and you have built what an engineer calls a box girder, the same cross-section that holds up a modern bridge. Depth resists sag. The vessel that looks least like a boat is, structurally, the hardest kind to break in the middle, all of which sounds like special pleading, until you watch what happens when someone builds a wooden ship this long and gets the structure wrong, because it has been done. Once, at almost exactly this length, and it is on the bottom of the Atlantic. In 1909, a yard in Bath, Maine launched the Wyoming. 6 masts, the largest wooden ship ever built, before or since. On deck, she ran about 110 meters, from the tip of one spar to the tip of the other, 137. The ark's length in the short cubit, almost to the meter. She was a magnificent ship and a structural failure. The moment she met heavy seas, her hull did the thing long wooden hulls do. She flexed. The bow and stern sagged. The middle rode up. The long deck planks twisted and pulled at their fastenings, and the seams opened. Water came in. The crew ran the pumps. They reinforced her, and she flexed anyway. And they ran the pumps again. For years, every heavy sea, water in the hold, and men working to keep her afloat. In March of 1924, she was riding out a storm at anchor off Cape Cod. Sometime in the night, the sea worked her apart. She went down with every hand aboard. No survivors. The largest wooden ship human engineering ever produced could not, in the end, keep the ocean on the outside. That is the wall. Push a wooden hole past about 100 meters, and it begins to tear along its own length, and the water finds the gaps. The Wyoming is what the ark's dimensions are really up against, not the storm. The length, which is why the last thing you would expect is for the numbers in Genesis to test well. And they do. In the early 1990s, 9 naval architects at a state ship research institute in South Korea decided to run the proportions. Not the theology, the geometry. They took the ratios given in Genesis and generated 12 competing hulls of the same displacement. Some fatter, some thinner, some taller, some shorter, and put scale models through the tests any hull has to pass. Structural stress under wave load, resistance to capsize, and seakeeping, which is how violently a vessel throws its contents around. Then they read the results. The biblical proportions landed near the top of the set. The hull could take the stress of very large waves. Their models held up under seas around 30 meters. It resisted capsize hard, heel it far over, and it returned upright rather than rolling under. And here is the detail that makes the results strange. When they changed the proportions, the design got worse. Longer, shorter, deeper, shallower. Stability or strength fell off. The ratio in the text sat close to the best the tests could find. Remember the cube. The floodboat in the Babylonian version, 6 equal sides. In this kind of test, a cube is a disaster. It rolls and pitches without rest. The proportions in Genesis are not the worst hole you could choose. They are near the best. Two things have to be said plainly, because honesty is the whole reason to do this carefully. The study was presented at a creation conference and published in a creationist journal, not a neutral engineering one, worth knowing as you weigh it. And it tested a set of proportions in a wave tank. It did not test whether this vessel was ever built or whether the waters ever rose. What it shows is narrower and still striking. As a matter of naval geometry, a long, low, rectangular box is a stable shape, and the ratio the text hands down is a good one. Where the numbers can be checked, they hold, which leaves the parts no wave tank can reach. The parts the text names with words we still cannot translate, starting with the first one. So, that word, gopher. There are 3 serious answers to what it means, and you can weigh them for yourself. The first, it is a tree, most likely cypress. The Hebrew gopher sits close to the old Greek and Latin roots that become our own word cypress, and cypress was the shipwright's timber of the ancient Mediterranean, tall enough for long planks, slow to rot in water. It is a clean theory with one problem. Hebrew already has an ordinary word for cypress, berosh, and uses it about 20 times elsewhere. Why reach for a word you use nowhere else if all you meant was cypress? The second answer says it was never a species at all. The 2 oldest translations we have, the Greek, made before Christ, and the Latin that follows it, do not name a tree. They render gopher as squared timber, as planed wood. To those translators, working with the language far closer to living than we are, the word described how the wood was worked. Cut square, dressed smooth, milled to fit. Not what it was. What was done to it. The third is the strangest and the hardest to wave off. Look at the same verse. The wood is gopher. The pitch that seals it is kopher. One consonant apart. Both are rare words. Both are thought to be borrowed from the same older Mesopotamian language, where the root carries the sense of covering, of tar. The wood may simply be resinous, pitch-bearing timber, named for the very substance it would be sealed with, the material and the sealant, a single letter between them. And here is the honest end of it. Open the standard scholarly lexicon of biblical Hebrew, find the entry, and it offers a single line. An unknown species of tree used for building the ark. 3,000 years of reading, 3 good theories, and the finest reference we have still records the wood, plainly as unknown. Now widen it back out, because gopher was never alone. The opening under the roof, the sohar, is not the normal word for window. The text has that word, shalom, and uses it 2 chapters later, when Noah opens a window to release a bird. Sohar is something else, rooted in noon and brightness, and the ancient translators could not agree what it was. An opening, a light, a roof. Later tradition gave up on architecture entirely and imagined a glowing stone that lit the vessel from within. The rooms are kinnim, nests. The vessel is tevah, a box, a coffin. Piece by piece, The features that matter most are set down in words that will not fully open to us. So you are left holding two things at once. Two things, and they do not sit together comfortably. On one side, numbers precise enough that a modern ship laboratory can build scale models from them and watch those models ride out a simulated 30-meter sea. On the other, a vocabulary so old that no one alive can say for certain what the wood was, or what the opening looked like, or why the writer reached past the plain words for ship and window and room and chose these instead. The plan is exact where you can test it, and dark where you most want to see. We can tell you the pitch was bitumen, a tar that seeps up out of the ground across the ancient Near East, common enough that the same book mentions pits of it. We can tell you why a box beats a boat here, and why the door had to be the strongest thing built into the hull. We cannot tell you the name of the wood. The most measured, most tested, most argued over vessel in all of Scripture is built, from the very first line of its instructions, out of a material we have never once been able to name.